Well, today I will talk about the PP-OCR or practical OCR or practical ultra lightweight OCR system. Firstly, I will introduce something about the OCR. Well, the OCR or the optical character recognition system have been widely used in various application scenarios, such as the office automation or the factory automation. And the OCR is a technology which targets at recognizing text in image automatically. And we have a variety of text appearance, and we can divide it into main category. Where the first is the syntax, as you can see in the left side of the presentation. The syntax is the text in image can be the text that refers to the text in the natural scenes here. And the second type is the document text, where the document text is often encountered in practical application. But the document text has some different problem due to the high density like this, or the long text to be solved. The next thing I will introduce is the computational efficiency. Well, as you know, that the images that need to be processed are usually massive, and it makes a high computational efficiency is become an important criterion for designing an OCR system. And in this paper, the CPU is preferred to be used than GPU. We need something.
Can you make one slide?
That's
So why CPU is preferred over GPU?
Well, the CPU is well, as you know that the CPU is a central processing unit, while GPU is graphics processing unit. And in the OCR, the image is really massive, but uh, but we need to the computational efficiency, and the CPU can process faster than the GPU. I think that's
No. I don't think that is the case. GPU much faster than CPU. So if you're talking about computational efficiency, it should be GPU over CPU.
But I think the GPU often for the graphic, but with some image to take to the text recognition, I think CPU is better.
No. I don't think so. I think the case they prefer it, I think because they deploy this system on the phone or mobile app natively, and I think they just need CPU, but for computational efficiency, they should be GPU.
Phuong, you can check it later and reply to Thang. Okay, then it must be reason. So check it a little bit more and then reply to the team later.
That's
fine.
Well, so to improve the computational efficiency, in this paper propose a practical ultra lightweight OCR system. is PP-OCR, and it has three main parts. The first is the text detection. The second is a detection both rectify or the last is the text recognition. And each part has their own strategies. The text detection has 6 strategies, while the second has 4, and the text recognition has 9 strategies. Now we will go to some enhancement for slimming strategies. For the detection, where in PP-OCR, we use the differentiable binarization, or DB, as text detector. And it is based on a simple segmentation network. And the first I want to talk is the light backbone. As you can see in the text detection, we have the backbone and the head. Well, about the light backbone, because the size of backbone has dominant effect on the model size of the text detector, so we use some ultra-lightweight model that are often used in backbone. Is the MobileNet V3, MobileNet V3, the MobileNet V2, the MobileNet V1, and the SafeNet V2. As you can see in the graph, the MobileNet V3 is the best, and it achieves higher accuracy when the predict time are the same. So for the choice of the scale, we adopt the Mobile V3 last is 0.5. The next is light head. Here is the head. Where for the convenience of merging the different resolution vector maps, the one-by-one convolution is often used to reduce the vector maps to the same number of channels. And if the inner channel reduced, we can have a great influence on model size. And we have test if the channel reduced from the 256 to the 96, the model size can reduce from 7 million to the 4.1 millions. But of course, it's followed by the accuracy declines, but only slightly. The third strategy is remove SE.
Wait me a second. Can you back to slide?
This or this?
One more slide. This is after we have concatenate all the features that we got, right? So you have two brand of prediction. So first brand is probability map, right? So another brand is like they take 1/4 of that and then they predict again with threshold map. So what is that?
You mean you mean this?
Yeah.
Well, this is a detection. This is a text detection, and this is if you want to know about this, this is talk more talk in the Liao et al. in another paper. And if you want to know more about it, I can share the paper now.
Okay. So you can move on.
That's Well, now I will open the paper, or I will keep up
No,
with
just moving on to your presentation.
this. Well, the next part is remove SE. Well, as you can see here is the architecture of the SE block, and the SE block is often in the net in the mobile net v3 because it contains numbers of SE block. But as we see, according to our research, this SE is not really important. If the input resolution is large, such as the 640 by 640, it's hard to estimate the channel-wise vector response to SE block. And the accuracy improvement is limited, but the time cost is high. And if we remove the SE block from the backbone, the model size can reduce from 4.1 million to the 2.5 million, but the accuracy has no effect. So remove SE is not really remove SE is not really effect to the model effect to the accuracy, so we can remove it.
So the SE is a diagram that you got color, right? Or the whole diagram in here, or the one that got color.
Well, remove SE is from this or this, and this you can see the between here and here, and it has a channel implicit and recalibrate channel-wise vector. The next is the current is the quotient learning rate decay, where the learning rate is a hyperparameter to control the learning speed, and the learning rate is really important in the deep learning, and the lower learning rate, the slower chance of loss value. And in this graph, you can we compare between the quotient decay and the piecewise decay, and you can see that the during entire training process, the quotient learning rate decay keeps a relative large learning rate, so its convergence is slower, but the final convergence accuracy is better.
No, I think this diagram is just the way that the training learning rate doesn't have anything to do with accuracy, you know. So epoch and learning rate doesn't have anything to do with accuracy, like you talked. We need one more diagram about accuracy, because I didn't see the accuracy in here. So talk about the accuracy.
Well, about accuracy, in the last of the presentation, we will talk more about the accuracy and about these strategies. And in here we only talk why we use this learning rate decay. It's only a strategy to decrease the model size.
I think it decrease model size, but yeah, you can continue.
This. So what do you mean?
No, it's the way they control the learning rate. It don't have anything to do with the model side, though. So it's just the way of training. It's not related to the model side.
That's it's not really to the model size, but it can have the convergency. It have convergency accuracy.
Yeah.
About the learning rate warm up, where this is taken from the another paper in 2019, and it shows that if we're using the learning rate weight up operation, it can help us improve the accuracy in the image classification. And for text detection, these experiments show this strategies is also effective. And they recommend that a small learning rate should be used. About the APGM pruner, where pruning is another method to improve the inference efficiency of the neural network model. And it uses the geometric median and in the Euclid space. And in another method, the pruning every layer uniformly usually leads to some significantly performance degradation. But in PP-OCR, the pruning sensitivity of each layer is calculated according to their method. That talk in another paper, and this to evaluate the redundancy of each layer, so we can reduce the degradation. Where next to is the second part of the computational efficiency. We have also have four strategies. The first is light backbone, where as I talk in the text detection, the MobileNet V3 is the best. But in the direction classification, we is a relative symbol, so we only use the mobile V3 small x 0.35 to balance accuracy and efficiency empirically. About the data augmentation. This is a take from another paper in 2020, and it shows that a base data augmentation is useful for direction classifier training, and they also get some new data augmentation operations proposed recently, but they can get the conclude that the run augment works best. The strategy is the input resolution, where in most previous text recognition, the height and the width of the normalized image is set as the 32 and 100. But in PP-OCR, because in PP-OCR, because the backbone is very light, So we can use the height and the width is set as 48 and 192. And we can conclude that it improved the accuracy of direction classifier. The last in the direction classification is the byte quantization. As you know that the quantization allows the neural network model to have lower latency, a smaller volume, and smaller computational power consumption. And as present, the quantization is mainly divided into two categories, the offline and the online quantization. And the pact is a new online quantization method that removes some outliers from the activation in advance. And this is the formula for the pact. As you can see here.
So why do people need to do the quantization?
As I have talked, quantization allows the neural network model to be lower latency, or smaller volume, and lower computational power consumption.
So what is the apply for? So if I have the GPU, do I need to do the quantization?
Well,
what the threat of quantization?
You do you mean if you use the quantization, what is what can what if you
drawback.
yes.
Yeah. So if I have the very strong GPU, do I need to do the quantization?
Well, I think they also need the quantization because because the image size is really massive, and if you do the pack and the quantization, you can reduce the you can fit some hypervector searching narrow architecture search, or the backbone and the head is the backbone and the head can be a liar.
So
I don't think it. So you talk about the input resolution in the previous slide. You only have two resolution. I don't think it makes sense.
This.
Yeah.
Well, Thang, then when people present, then we will support them. Okay. So just make sure that people understand what it is, because if some of you guys never use it before, never done it before, so perhaps like you might misunderstand why people using it and why it have. So if we have very strong GPU, we might not need quantization, and quantization is using to compress the model. So you see that is we have a million of parameter, for example, right? And to run through the network, then it take a lot of time. So and a lot of computations. And if we want to use on the mobile devices like phone, right? So in the phone we have only CPU, and they have a bit of power for processing the computation, but it's not as strong as the GPU or on the desktop. So people need to just imagine like last time you have deployed the model on the simulation and the mobile on the model on the real device. The differences of the time is one is only like 100 millisecond, another one is 2 minutes, because of the power of the GPU simulation in the simulation is not strong enough, so it run really low, right? So really slow, and for the GPU, then for the CPU, then on the real device, then it will run really fast because it's very strong. So it's applied the same. So if you want to so in that case, if you do want to want it work on the simulation, then you need to compress the model. So it's like the same like quantization here. Okay. So the answer, if you have strong CPU, you might not need the quantization, except for that you need to process a lot of cases. Second thing is the trade-off between the what is the trade-off of the quantization. So you gain the speed, and what you lost, or everything okay. So you understand the word trade-off, right?
Mean
It means like you need to sacrifice something for something.
yes.
Yeah. So you do the quantization, you got faster, and what you lost?
Of course,
What do you win lose?
well, if you use the quantization, you will the higher quantization loss.
Now the loss is okay, but the thing is, what do you? I want need the one like the end user. I don't care about like the deep tech inside, but I have the faster version. Then what you usually what I lost.
Well,
So let's say when you typing computer faster, then what you will have problem.
Well, I think the accuracy can decrease.
Yeah, that's correct. Like Sun demo that when Marco demo when he doing on the computer, right? So the accuracy very good on the server, very good. But when you move to mobile, then the accuracy get less. So that is when you pruning. So people using word pruning some of the parameter and some of layer branches, then the accuracy is usually when get lower than if we're not using quantization. But they have the trade-off between those. So if they prefer the speed, then of course they need to sacrifice a bit about accuracy. Okay, so okay, so during the presentation that we will help you guys all to understand more a little bit about like why people using it and why is when we should using it and when we should not. Okay, and when if for example for the car project at the moment, we don't care about speed, we care about accuracy. So sometimes it take like 2-3 minutes to process the photo, but as long as it's work, then we're happy. But for the OCR, for example, then we might prefer the speed if we process a lot of document. Okay, so okay, moving on. So you got it right?
Yes.
Yep. So anyone have a question regarding to those quantization? Okay, so if you guys have any like criticize, then just ask question right away. Okay, so I need more. I need more reaction from you guys. Need more interaction.
Actually, quantization is a new thing for me. I learned about it right now. So I don't really have much to say.
Okay, keep moving on then. Yeah.
Yes. Well, the next thing the next part is the text recognition. Well, the text recognition has 9 strategies for enhancing the model ability and reducing the model size of the text recognizer. Where the first is also the backbone. Well, in text recognition, the mobile v3, mobile net v3 small x 0.5 is selected to balance the accuracy and efficiency in practically. And the next is the data augmentation. Well, besides the PDA, as I talked in the second part, um, which is often used in text recognition. In another paper of tier, also is an effective data augmentation method for the text recognition. So the BDA and this augmentation can give the can make it more better. And here is the TA from the paper. The quotient learning rate decay is also taught in the text detection. Now we will talk about the feature map resolution. Well, in order to adapt to the as you know that the PP-OCR have a lot of language. So in order to adapt to the multilingual recognition, is particularly some language like Chinese. The CNN in the OCR is set to 32 and 3020. Then the stride of the original mobile net v3 is not really appropriate for the text recognition. So in this figure, for the sake of the keeping more horizontal information, we modify the stride of the down sampling feature map except the first one from 22 to 1. And in order to keep vertical information, we modify the stride from 2-1 to 1-1. And so the stride of the second down sampling feature map S2 affects the resolution, the whole feature map, and the accuracy of text recognition dramatically. If you want, you can read more about this in this paper. About the regularization parameters, where in machine learning, overfitting is a common term, and to avoid overfitting, many regular ways have been proposed, and the weight decay is one of the widely used to avoid overfitting. So for text recognition, the L2 decay has a great influence on the accuracy. The next is the learning rate warm-up, where it's also introduced in the text detection. The light head. The light head in text recognition is a bit different from the text detection. In text recognition, a full connection layer is used to encode sequence factor to the predicted character in the ordinary. The dimension of sequence factor have an impact on the model size of text recognizer, especially in some character like Chinese, which whose character are more than 6,000. And in PP-OCR, the dimension of sequence factor is set to 48 empirically. The next is pack quantization, where is also talked in the second part. And now we will go to the experiments. First is the setup. As you can see, here is the data set. Well, for the data set here is for the text detection. Here is the data set for Chinese and English recognition. For the text detection, the total data set is 97 training images and 500 validation images. Among these, we have 68,000 images in real scene image. It often comes from the public datasets and by the Baidu image search. And the synthesis, that means the words that is not really easy to recognition is 29,000. And similar to the direction classification and text recognition. And this is datasets for the multilingual recognition. Well, this table shows you the implementation details of the model training. Well, this paper is the Adam optimizer to train all models and adopt quotient learning rate decay as the learning rate schedule. And this is the initial learning rate, the batch size, the ablation data, and the total data for the text detection, direction classification, and text recognition. And now we will come to the text detection. Well, this table compares the performance between performance of different backbones for the text detection. As contain 8 mean, the model size, the inference time. As you can see here, the 8 mean is not really different, but for the accuracy and efficiency, you can see that the model net v3 last is 0.5 is the best, and we have talked that in the text detection of the in the last part. This table shows the ablation study of inner channel. In the removes SE, the quotient learning rate decay, the learning rate warm up, and it has the precision, the records, it means the model size and the inference time. The first is the inner channel is the 256. And the second is also that, but the inner channel reduced to the 96. And you can see that the precision is reduced only a little, but the model size reduced by 41% from the 7 to the 4.1. And the third, we remove the SE. The precision is increased, and the model size is decreased. And if we continue to apply the quotient learning rate decay and the learning rate warm-up, the result is like this. So, in conclusion, using both the quotient learning rate and decay instead of fixed learning rate and learning rate warm-up, it means will improve the obviously. This table shows the application study of FPGA pruner for the text detection. As you can see, the model size reduced from the 2.6 to the 1.4, and it reduced 46.2%, while the inference time reduced by approximate 19%. About the direction classification. Here you can compare three backbone, and as you can see, the accuracy of the mobile V3. Here we use the MobileNet V3 with the different scale. And as you can see, the mobile V3 small x 0.35 is as much better than the mobile V3 small 0.5 and the sharpness V2 0.5. This table shows the application study of data augmentation for direction classification. The baseline accuracy is 88.79%. When we adopt the BDA, it can boost by 2.55% to the 91.34%. And for after these issues, we can conclude that the BDA and the range almonds give us the best result. Here we can see the application study of input resolution and packet quantization. You can see here the accuracy, the model size, the inference time, and when they use the back quantization, the accuracy is really good, while the model size is decline very much, and also the inference time. The last is the text recognition. In this table, we compare the performance of different backbone for the text recognition. Here's the accuracy, the model size, the inference time. And for text recognition, we choose the mobile V3 small 0.5 is the best to balance the accuracy and efficiency. This table shows the application study of the number of channels in the head for text recognition. The data augmentation is only used the BDA. And you can see that, and this is used in CRNN head for text recognition. If we reduce the number of channels from 256 to the 96, the model size reduced from 23 million to the 8 million. And the inference time accelerate nearly 30%. So so you can see that the number of channels have a really great influence on the model size. This table, you can see the ablation study of data augmentation, the quotient learning rate, decay, the stride, etc. And you can see that when we use the BDA, the accuracy will improve. The accuracy will improve, and when used, when we use the quotient learning rate, the accuracy is of course is increased too, while the inference time is not really affected. So we can see that the data augmentation and current learning rate is really important to the accuracy. And here's the practice quantization for the text recognition. So you can see that when we use the PACT, the model size reduced from 8.1 to the 3.5, about 75%. And the inference time also reduced from 306 to the 268. So now we will talk about the system performance. So you can see that when we use the slim approach, the model size will reduce, but the F score is not really impact. Therefore, the APGM pruner and the pack quantization are also effective strategies to reducing the model size. This figure shows the image of some image results of a proposed OCR system. Here, we compare the ultra lightweight OCR system and the large scale one. And here is some image result of the PP-OCR. It's also recognize the text quite true, while the model size is much smaller. Well, my presentation is end here.
Yeah. So I think we should modify the Pablo statement a little bit about back quantization, so it's not trade-off between accuracy and speed, right? It's a win-win situation when it increase accuracy and also increase speed.
Yes. Well, I think when they use back when you apply the back to the quantization, they reduce the quantization loss.
Can you open the table about back quantization, the table about experiment?
That's
Yeah.
here.
So it also increase accuracy and also reduce the speed in front time. So it win-win situation, not trade-off. So it's very interesting. So yeah. Can you go to the slide where they compare the system in the CPU and GPU? The last few slide, last few table. Yeah, you can see in here. So the difference between CPU and GPU. So GPU is much
CPU
faster.
is that's
So anyone have any question about this presentation?
Yeah. So about pack quantization, actually, I understood quantization, but how is like pack quantization?
what can you repeat the question? I have
Yeah.
the environment is a little noisy. So can you repeat the question?
I think Pawat asked about pack quantization.
Yeah, like I understood quantization, but what is pack quantization? Like, how is it like making the accuracy better?
So from my point of view, it's like you can think of it, it's like activation function, but not really apply for every single layer. But I think they apply in a few milestone of model. I'm not sure, but you can think of it like activation function, like ReLU. So they try to remove all the parameters that not in the range of interest. So it's like negative alpha and plus alpha. So I think you can think of it like activation function, something like that.
The pack method is based on the ReLU function.
Yeah, something like that.
Yes, and the pack has two paper, and you can read it in the in that paper more to get more knowledge about the pack quantization.
Okay.
How about the other? Do you have any question? Talk more, man. Talk more, please. Han, can you let me check then which slide? So you guys don't have question, then I have question for you guys.
Yeah, like I wanted to know what other backbones we can integrate to this one. Like I read in the paper, they have used the mobile net backbone. Can we use other backbones to like ResNet or VGG16?
You said can we use the pack for the ResNet?
Yeah.
Where the back is quantization. I think the back is quantization and is based on the rules, so I think it can apply to the ResNet.